Hello everyone. So today our topic of discussion is Rolle's theorem. Rolle's theorem. So to apply this Rolle's theorem, we must have a function fx which is defined in the interval a to b. So this fx should be given and this interval a to b should be given where a and b both are included, and this fx should be defined in this interval a to b. So according to this Rolle's theorem, there are three conditions that should be satisfying. So the first condition which should be satisfied by this function fx is this fx should be continuous in this interval a to b. Okay, so what is the first condition? The first condition is the fx function which is given to us, that should be continuous in this interval a to b. So let's write that. So this fx should be continuous in interval a to b. So this is the first condition. Now second condition. What is the second condition? Second condition is this fx, this should be differentiable in the open interval a to b. So let's write that also. This fx, this should be differentiable. This should be differentiable in a to b where a and b are not included. So this fx, this should be differentiable. This is the second condition. Now let's see the third condition. The third condition is f of a should be equal to f of b. What are these a and b? A and b are these points, the interval, the starting point of the interval and the end point of the interval. So this f of a and this f of b, these should be equal. So these are the three conditions that should be satisfying. So if these three conditions are satisfying, then according to Rolle's theorem, there must be a point C. There must be a point C. There must be a point C in the interval a to b. In this interval a to b, there will be a point C such that f of c, f dash of c, that should be equal to 0. That should be equal to 0. So this is the whole statement of Rolle's theorem. Now what is the significance of that and how to apply that theorem? So to understand that, we'll take some examples. By that you will understand this better. Okay. So first of all, to understand these three conditions, okay, we'll take some examples. Okay, so if a function you have given that is like this, this is a, this is b, and this is function fx, this you have given. So obviously this point, this will be f of a and this will be f of b. Okay, so this f of a is equal to f of b, that we can clearly see. Now let's see all these three conditions, these are satisfying here or not. So the first condition is fx should be continuous in a to b. So this is the interval a to b. In this fx should be continuous. But clearly we can see at this point this fx is not continuous. So here the first condition is not satisfied. So we cannot apply Rolle's theorem here in this question. Okay. Now see another question or another example. Now if we have given a function like this, this is a, this is b, so obviously this will be f of a and f of b, and this is a sharp corner here like this. This point is what? This is sharp corner in this graph. So here, now let's check these three conditions, these are satisfying here or not. So the first condition is fx should be continuous. So this function fx we have given, this we can see this is continuous here. So first condition is satisfied. Now the second condition is fx should be differentiable in a to b. Now this function fx is differentiable or not. So by graph, how we can observe the function is differentiable or not? Now to understand that, we know that if there is a sharp corner in the graph, so at that point the function is not differentiable. So here we know this is a sharp corner. So this function will not be differentiable at this point, because at this point infinite number of tangents can be drawn. So the second condition is not satisfying here. Okay, so again we cannot apply Rolle's theorem. Okay, now see another example. Now if we have given this function fx like this is fx, this is point A, this is point B, so obviously this will be f of A and this will be f of B. Now let's check these three conditions again for this graph. So here fx should be continuous in into B, so this is continuous function here. Fx should be differentiable, so no sharp corners, so this is differentiable also. Now f of A should be equal to f of B. Now see this, f of A is this and f of B is this. There is a huge difference in there. We can see this f of A is not equal to f of B. Okay, so again this third condition is not satisfying. So here again we cannot apply the Rolle's theorem. Okay, so all these three conditions, when these are not satisfying, that we have seen. Now let's see when we'll apply this Rolle's theorem. Okay, now for that let's take one example. So x square minus 5x plus 4. Let's suppose this is function fx we have given and the interval we have given is 1 to 4. Okay, so we'll apply Rolle's theorem here. So we know now first of all we'll check these three conditions. The first condition is fx should be continuous in this interval a to b, or here in this case 1 to 4. So this is fx is a polynomial function and we know all the polynomials are continuous. So here this fx will be continuous here. Second condition is fx should be differentiable. So graph of this function fx, that should be a parabola and coefficient of x square is positive, so this will be a upward parabola. And we know the parabola graph is what? Differentiable in all its domain for or for all values of x. So this is differentiable also. Okay, or we can draw graph of this easily. Okay, so we can observe from there this will be differentiable also. Now f of A is equal to f of B, so this we have to check. Now f of A, what is A and B here? A is 1 and B is 4, because interval is what? A to B, here interval is what? 1 to 4. So A is 1 and B is 4. So we'll check what? F of 1. So f of 1 means what? In this fx we'll put what? 1 in place of x. So this will be 1 square minus 5 into 1 plus 4. So this will be what? 1 minus 5 plus 4. So this will be 4 plus 1, 5 minus 5, that is equal to what? 0. Okay, so this f of 1 is what? 0. Now f of 4 will calculate. So f of 4 will be what? 4 square minus 5 into 4 plus 4. So this will be what? 16 minus 20 plus 4. So this will be what? 16 plus 4, 20 minus 20. This will be again what? 0. So f of 1 is equal to f of 4, because both of these are 0. Both of these are equal, that is equal to 0. So this third condition is what? Satisfied here. So all these three conditions are satisfied. So we can apply Rolle's theorem here. Okay. So according to Rolle's theorem, there must be a point C. Okay. So let's check this point C is there in this interval 1 to 4 or not. Okay. So f dash of x will be 2x minus 5. That is differentiation of this. Fx is this. So its differentiation will be this thing. Okay. 2x minus 5. So let's suppose that point C. So f dash of C, so this will be 2c minus 5, and f dash of C is equal to 0. So by applying this, we'll find out value of C and we'll check that C that we are getting, that is in this interval 1 to 4 or not. Okay, if that is there, then this Rolle's theorem will be verified. Okay, so this f dash of C means 2c minus 5, this will be equal to 0. So from here C will get 5 by 2, that is 2.5, and we know this 2.5, this belongs to this interval 1 to 4. So 2.5, this belongs to 1 to 4. So hence this Rolle's theorem is verified from here.